Yeah, sorry everyone. Sorry for keep you waiting. So let's begin. So yeah, hi everyone. Welcome to this week Extract Data Live. Today we are going to dive into something that sits at the core of many AI systems, but also connects closely to our world of web scraping, common crawl. So yep. So you have probably heard the phrase at some point, that LLMs are trained on the data from the web, but that raises a question: how exactly did they get the data? Did they write scrapers to crawl the entire web? Did they build their own large-scale web scraping solution, or was it something else? So, well, the answer for many of them is Common Crawl, an open source project and a non-profit organization that has been crawling the web since 2008. It provides free, large-scale, publicly available archives of web data that the researchers, developers, and organizations worldwide sort of rely on. So if we get a bit into the uh, depth into the insights, so like how many LLMs relied on. So if we look at the report from Mozilla from last year 2024, they analyzed 47 generative LLMs released between 2019 and late 2023. So they found that nearly two-thirds, that is about 30 of those models, used common crawl in some form. 10 were unknown and 7 didn't revealed it. So fast forwarding to today, Wikipedia lists over 80 plus LLMs, and if we look at the proprietary LLMs, right, it makes it 120. But if you look at the third party like Open Router, they provide access to 500 plus models. So that makes really loads of models are coming up, right? While not all of them disclose their data sets, common core and its derivatives remain some of the most commonly cited sources. And it's very likely they continue to form a core part of training data for many new models. But does that mean you no longer need to write tricky scrapers? Well, not exactly. Common crawl gives you access to web data at scale without worrying about rotating proxies, bans, and other scraping headaches. But it also comes with its own limitations and challenges. That's what we are going to dive today in some time. But we'll talk about like when common crawl is the right choice, when you might still need to build your own scraping solution. But before that, let's take a look at what common crawl is and how it works. So, as said, it's a non-profit organization that crawls the web and publishes the dataset freely. The goal of common crawl was, like when it started, was just to provide the free and open access to everyone. And if we talk about what they exactly do, they crawl billions of pages monthly. They contains petabytes of data regularly collected since 2008. You can find archives for each month from each year. If we talk about the last month of August, they added 2.42 billion pages that were 419 of raw and compressed web data. So, and we'll talk about the files, like how in what formats common crawl save this data. So but one of the common file is in the web archive file. So they store this whole data in the S3 buckets. It can be accessed inside the from the Amazon S3, but we can also access it via the HTTP, sending the response to their API. uh, so yeah, one important thing is, they have while crawling this up, they have used their CC board, but that respect robot.txt. They do ethical crawling, right? And one more thing to understand is they don't crawl the complete site, right? It is just the partial pages of it. So, and mostly the HTML's data is available. For some sites, you might find images, videos, but it's mostly the HTML to keep the fair choice of uh, like the ethical use of the public data. Okay, so if we quickly talk about like how common crawl works, it's quite a simple diagram. But once we get into the code, you will understand how it relates. So first step from the common crawl side is they crawl the web every month, and they have they put that crawl data into their archive, and Then they have something called CC dump. So CC dumps is nothing but it is a name given to like a monthly archives they have. So if we need the data, we need to filter those CC dumps, right? I need to select, I need the data from the August dumps, I need the data from the July dump. And then inside those dumps, I need to navigate through the web archive files to find the exact page I need to get. And then I got the raw data of it, and then I need to parse it, or I can fed it to LLM to get me the uh, sort of the context through it. Data from the August. Yep. Next, talk about the CC file formats. So, now that we know that like what common crawl is, let's look at how the data is stored and accessed. Common crawl offers, its data in three main formats. So one is the web archive, then we have the web archive transformations, then we have the web extracted text. I would say the main one is the web archive, and these last two are the sort of extracted version of it. So but each serve different purpose depending on what you want to do with that, with the data. So if we talk about the first one, web archive files are the most raw form of crawl. So they contain the full HTTP responses. So you get the actual HTML content, headers, everything the web server sent back. So if you want to extract images, parse custom HTML structures, or dig into the full page content, web archive files, like web archive should be the choice for this. And if we talk about the next one, we have the web archive transformation. So they are like summaries of the web archive files. They contain the metadata in JSON format, such as all the links that exist on that page, and the HTTP headers and some of the response codes. So this is useful if you don't need the full page but want the structured information, like which URL links to which page, right? And if we talk about the third one, there is a web extracted text. As the name says, it's just the text content from the web archive file. All the HTML images formatting are removed, and it leaves the only the plain text. And this is ideal for text analysis, natural processing tasks, or training language models, because you get clean readable text without the clutter. And uh, if we just to make it more simplified, think of it like receiving a package from online store. That is a common crawl, and web archive is like the full package with the box. And then there is a packing material and all the items inside. And this uh, web extracted text is like a receipt that list sorry, a web archive transformation is like a receipt that lists all the items in the package. And like you don't see the items themselves, you just see the information about them. And web extracted text is like unpacking the items and keeping only the usable content. So yeah, I think that makes it clear. So these are the three ways we can get it. And I think I said the first one, web archive, one is the mean one, and these are just the transformations and the text extracted formats of this. So, and as I said, you can access this via the AWS S3 or via the common crawl index that we are gonna do today, or you're using a Python library like VerSeo2. So I said, they have the CC dump. So it's a really large amount of data they have, right? So yeah, I need to decompress it. So let's talk about, yeah, let's dive into the code itself and see how you can fetch the pages from the common crawl, how you can fetch the data. Yeah, decompress it. Yeah. So we have four steps in total. If you want to use the common crawl, so I would say the first three steps. Yep, I think it's visible now. So the first three steps are, in common. You can use them for any of the uh, like any of the URLs you're trying to fetch. But just make sure, sometimes it is not going to respond back with the pages. It might be the API we're sending the request is overloaded, or it might be the page actually doesn't exist onto the common core database due to some legal reasons, or it might be the robot.txt doesn't allow their CC port, which crawls the pages, to get it into their database. So yeah, if we talk about the step one, we have the common crawl and index retrieval. So I said you right that there is a CC dumps that exist for each month, like for the August, for the July, that they scrape the web each month, right? So we need to navigate through it and find those available indexes. So if you can directly also pass, like if you are sure that this page is going to exist into this index, you can just pass that, right? So even if I show you the dumps for a while, you go to the common core site and you can go to the resources. Let us scroll, and yeah, you can see this. The last scroll was this 225, that was from the August. And even you can, if you get started, you can find the list of roles from here. So we try to just, find our page by indexing each of these. So let's get back to the code. Yeah. So, this section introduces the common crawl API interaction for us. So, we, this get available index function, it fetches all the available, common crawl index collections that are available, that just I showed you onto the common crawl site. So, these are sort of, the periodic roles. So, also, one thing is important to note, like here first we go to this index.common crawl organization called info.json, so to find where our page lives. So I'm trying to, target some uh, uh, sort of, computing graphic card site. So I'm just trying to figure out like in which index it exists. So by sending the request to this index.commoncrawl.org, you find where our page lives. The index, doesn't gives us the page itself. It just tells us, which web archive file. I told you there are three formats. So which web archive files, and its offset and the length of that target page where they exist. Once we have that info, we go to the another URL, that is data.commoncrawl.org. So we have that in another step where we capture the exact page. So we with that URL, we actually download the web archive file chunk, and in that chunk we get that HTML content that we need. So yeah, so yeah, this function, makes an HTTP request to the common crawl API, and I think the import, but once we make this request, we just, get the API URLs from this responses, and we sort them into the reverse order, like from starting from 2008 to the current one. And we can also set the limit, that is on us. But this is the first step in any, common core workflow, finding which indexes are available. So once we find these indexes, in the step two, what we do is, uh, this function, as I said, searches for specific URL within the common core index. So we got the index URL right from above, and then we search for the specific URL. So the target URL, we want to find it in the archive, will be captured in this step. So there are four these important parameters that we need to pass on while searching for this URL. So first one is the URL we are searching for, then the output JSON, the filter code we set as 200, so reverts back that yes, it exists. And then the fields we need, like the file name, offset length, timestamp, so that once we get the response back that okay, this uh, URL exists into this index URL, we know its location, and once we get that web archive zip compressed chunk file, we can locate our HTML into it. uh, but one thing please note here, like this output JSON doesn't mean like we get the web page in the JSON format, right? It just tells the common crawl index where we are sending our request, that to return the metadata about the captures in JSON format. So things like which web archive file the page is in, so where this page actually exists. So and its offset, length, timestamp mentioned here are going to help us to locate it. So basically it's just a map to find the actual page, right? And the real HTML content is still inside that web archive file, which we download and parse in later steps, right? So we're just navigating inside a map to find our URL if that exists into this index URL. And so once we get the response back, we will get the metadata containing where the actual content is stored, right? And then results are sorted by timestamp, the newest first, like okay, if this index has it first, or if the July index has it first, right? Some index you will see when I run the response that they don't even respond back. So that means in that particular crawl of the month, this page was not crawled by common crawl. So I think that is also one of the challenge when you use the common crawl. Sometimes the page exists in some index and sometimes it doesn't exist in other, and sometimes it exists in all, and that brings up the loads of redundancy and duplication, and you need to deduplicate the data, right? So uh, yeah, so once you get the response from here, like you get the location, like where your page will be in the index, you try to capture its HTML. So like try to capture that page. So uh, okay, so like the in this capture, we got these responses from above, like from here, like there's the URL, the length, that we'll try to locate. So as I said, the complete these CC dumps, the web archives of each month crawl from the common crawl are saved into the AWS S3. So once we find the location, like where they exist, we can navigate through this URL, like data.commoncrawl.org to that. And we extract the web archive file name and byte range from the capture metadata. With that, we will able to find the starting length of our HTML and the endpoint of it. And once we have that, we can easily navigate to that, right? And we can parse it or just save that HTML part. So like in this step, once we send the response, we'll construct the full URL to the web archive file. And okay, and in this step, once we send the request to this S3 URL, like where you find the location, we make this get request, and we download a temporary zip compressed file, from this data common crawl. So that is the web archive file, right? That's a temporary file that we download, and that is downloaded via this, like the capture that we got from the file name, offset length, and S3 URL. And then we in this step, like when we got this file, open it, and we just start a loop to iterate through it using this archive iterator. And as I said, we can use two libraries like Versio and the another one, so to decompress this file and navigate through it, since this is the huge file. So like not that much use in our case, because we got the length and the offset. But if you download the complete dump, I think it is going to be the terabyte of data, you need that much of the storage. But yeah, we just get the part from that web archive file because we have the location, right? So once you get there, we need to navigate through that web archive file, and uh, once we navigate through this temporary file, we extract the actual HTML of the page, and uh, uh, yeah, and that's what we pass to the next function for the parsing. And yeah, so now just to summarize this up, uh, how this is done, and before we move to the parsing one, I think in this we just get the HTML and we do the parse. So still let me just summarize these three steps. So now there were four steps, three were in the common, which were the main one to fetch. So first step, we send the request to the index URL, like to find the indexes, how many CC dump exist. And once we have found it, we try to check if our URL exists into it, right? Once we found that URL existence, we try to locate it, like in like see one uh, web archive file is in the terabyte format, right? Like for Augusta, I said I think around it was 400 something terabyte, right? If you download that much of storage and try to navigate through it, it's going to take a lot of time and a lot of resources. So uh, we once we have found the index and located like where the our URL the page exists, we just find its like the this its file name, offset and length and the timestamp, and then in the second step we just try to capture that part, right? And once we have captured it, in the next step we download that part of that CC dump, and in that also we try to look for our URL with this archive iterator in that web archive file, right? So there is a huge 400 plus terabyte of complete month crawl. In that we find a smaller portion of the web archive file, that incomplete web archive file, which is the complete month. We find a small portion, and in that small, once we download a small portion, in that small portion we'll find our page, right? So and then we need to parse it, or if you need the direct HTML, you can keep that, and it's just a main function that we use to run it up. So if I send the request to that, so see, we first fetch the list of available common indexes, and we found 115 available indexes right now. And if we, as I said, it starts from back like last year, and then we go to the recent year. So in the reverse order, the August one is the first, that is 2025, 33. So see, in this we couldn't find our targeted page, right, for the graphic cards. But if I look into the, I think this was the July, and we found one capture, and we use this capture to save as the temporary file, which is this, right? And then in this third step we try to uh, capture our HTML through it, and we save that HTML, right, the complete page, and then we use the parsing function to just get our product list from it. Yeah, so but see, we did this with common, right? If we needed a product like it was a single page, right, and we need to send the request, we need to parse it. I think that difficult part was to just go through this HTML and just write a parsing logic. You can use any LLM that can do it for you, but then it is going to cost you separately. So but if you want to do it in a simpler way for just a small product, I think at that time you need to write your own crawler or use some scraping API. But if we talk about like the major challenges that come up with a common crawl, right, you get this data for free. You don't need to struggle with any anti-ban or rotate your proxies or do stuff. But if for example I use one dump, right, if I need the graphic cards for like details for uh, uh, July, February, right, and I'm just trying to create the historical chart when the prices of the graphic card is gonna be less, right? But the thing is, February dumps, March dumps, April dumps, right? If I'm getting the indexes from all three of those, they will contain the same graphic card into the multiple like there will be a duplicacy of those graphic cards, right? It's okay if they have a different price, right? That will help me to analyze and create that historic graph. But if the price is same, the index IDs, everything is same, right? It won't make any sense, right? It is just I'm getting a chunk of data which is of my no use, right? In that cases, I think it's good to write your own uh, crawler, or like use some scraping API. So for example, if I show you the similar thing I did it with the auto extract of Zyte API, like it's, I think, just few lines of code, 15 lines of code. Rest is just, just we are printing the and saving this file. So if I run this up, you will see uh, how quickly we get this complete data. And uh, I think the common code and writing, both of their pros and cons. So we look at the challenges, like, and we'll also see like when you should use common crawl and when you should use this, like writing your own crawl or writing this own scraping logic. But yeah, so we got this response from the Zyte API to extract, and if I try to show the comparison of these two to use, yeah. So see, we got this is from the common crawl, and this is we got from the like the auto extract of Zyte. So we can see this one, I think, yeah, this one too matches up, right? But if we look at this second one, this one, these are different, right? So this is the latest one we have got from the Zyte auto extract from the live page. That is also, one another thing. If you need, if your task relies on the fresh data, I think at that point it's good to write your own crawler, your own crawler, or use the Zyte API, just to get the fresh data. But if you're working on something which relies on lots of data, right, and you're ready to struggle up with the deduplication of the data, just writing the parsing logics and everything, I think at that time you can shift to this. Or if you're working on some sort of research, or maybe you uh, need to do some natural language processing task, I think in that case, you can just use the web, that another format of the file that we have for the from the common crawl, uh, which was, I think, yeah, the web extracted text that we had. uh, so yeah, let's jump back to the So yeah, as I was talking about the challenges, so like they contain, I said, they contain multiple captures. We look at the example with the February, March, and April. Like if you are building a historic chart, so you need to deduplicate lots of stuff, right? And as I said, they capture the complete HTML from the page, right? So we'll get lots of ads, right? Lots of metadata from it, like a bold paid codes. And sometimes, the, as I said, they behave very ethically. They don't go and scrape complete domain. So there you might find some partial HTML, right? You might find some page halfway. You don't know what exists into the complete page, right? And if you look at the scale, it is also beneficial, and it is also not. If you are building some small project, right, small e-commerce store task you have, at that time, I think that petabytes of data, and finding the location length, as we see, we need to locate it, that becomes a bit tricky, right? At that time it is sort of hard to use it. And there is a bias, so we don't know, like, for which month what was the crawl frequency of the CC bot, like the common crawl, how much, for example, for some for example, for any site, they crawled like the initial pages for that month. In the next month, they called the next part of it, right? You don't know if they crawled it completely again. And sometimes some websites will have a good quality of content, right, which is easy to capture. Some might have different way of the structure that it is not able to capture. That time you will have a biased data for some sites, right, if you are feeding it to your LLM. And even if we look at the DeepSeek report, they alone remove nearly 90% of repeated content across their 91 terms. So just to train on the high quality. So even if I show you this report from research, like, they have the pre-training data. And if you look at the terms they have used, like 1 to 6 12, so these are the numbers of the month. You can connect this with the control terms from here. Yeah, we're gonna do it later on, but you get the idea, right? So they see the deduplication rate, and one thing you will see as the dumps they are moving and the deduplication rate is increasing, right? So that means the CC bot crawled the same data again for the next period, right? And in this last terms they use it is around 90%, right? So it depends if we are going to, if you're building something, training up there, and I think it is a beneficial tool in some way, but it has also its limitations. uh, so coming to when to use this and when to use a scraping API, as though we already discussed this into the challenges part. But use a control if you need a vast raw data, you're not specific to any site, you are just looking for some uh, completely raw data to train your LLM, or doing some research. At that time it is good to go with it, or you're building some historical archives, as I give you the historical example. If you're building some e-commerce store, or you might be looking for the graphic card historic data as we used in our example. So uh, or you're exploring it for academic experimental projects that don't uh, need that much of the perfection, right? You're okay with the deduplicate, like the data being repeated, right? You're okay with that. But it is gonna burn your tokens a lot of that if you are even running through it the LLM. But yeah, and use the scraping APIs if you need a fresh up-to-date data, as I showed you this in the comparison example. When I sent the request with the when I send the request with the Zyte API, and we use the auto extract with a few lines of code, and we get the latest fresh data. But in the previous data, we didn't see this MSI RTX 580 gaming try OC graphic card listed, right? Which was in a second in the list, but it doesn't exist here. So uh, yeah, you might lose that fresh touch of the data, but yeah, and if you want to be consistent, completeness, that you okay, I need a completed, I don't want to miss, as I said, with the control you might get the partial content, the pages that they have picked up might not be uh, the complete from any domain, right? They keep it ethical, so they don't do it, right? So at that time you might get loss of the data. So if you want to be consistent, just build your own scraping solution, or stick with the scraping APIs like Zyte API. And I think the auto extract feature with the minimal cost help you a lot of get a lot, lot to save your time. So you want to, if you want to have structured data, like with auto extract, I just send the request, I don't need to do the parsing or anything, I just go to the JSON response and saved it. So, and as said, if you're targeting some specific sites, then use it. But if you are trying to train some LLM, or uh, just for learning purpose, I would say you can add a layer of common code, right? First, I will provide you this code. This code can come handy. You can just add a layer of this code, and then you can pass your initial request via it. If the page exists there, right, you can just fetch the data from there. But then there is also like uh, no surety that if the data is gonna be complete or not. But yeah, I think it might come handy. So yeah, I think that was it, and I will share this PPT and the complete code in the exact data community. So you'll find the link to the community in the description of this live. Just go and join it, and you'll find the event archives channel there, and you can find the resources there. And if you have any doubt, yep, if you're in doubt, you can just put it into the community or in the live chat. I will just look after this, and happy to answer those. So yeah, thank you.